Programming is like giving instructions to a computer. Imagine you're a director, and the computer is your actor. You need to be very clear and precise with your instructions. Otherwise, the computer won't know what to do. Every single action, no matter how small, needs to be spelled out in the code. We tell it what to do step by step. This is the essence of programming. Each line of code is a specific instruction that the computer follows. But what happens when we need the computer to make choices on its own? But sometimes, we need the computer to make decisions. Just like in real life, where we make decisions based on different situations, our programs need to do the same. This is where the concept of control flow becomes crucial. This is where control flow comes in. Control flow is the order in which individual statements, instructions, or function calls are executed or evaluated. It allows our programs to take different paths based on certain conditions. Control flow lets our programs respond differently based on conditions we set. For example, we might want our program to perform one action if a condition is true, and another action if it is false. This makes our programs more dynamic and capable of handling a variety of scenarios. It's how we make our programs smart and adaptable. By using control flow, we can create programs that can react to user input, handle errors gracefully, and make decisions based on data. Imagine a program that checks if a user is old enough to vote. This is a simple example of control flow in action. The program needs to evaluate the user's age and then decide what message to display based on that age. Control flow allows us to check the user's age and display the appropriate message. If the user is 18 or older, the program will proceed with one set of instructions. If the user is younger, it will follow a different path. If the user is 18 or older, the program might say, "You are eligible to vote." This is done using an if statement, which checks if the condition is true. But if the user is younger, the program would say, "You are not yet eligible to vote." This is handled by an else statement, which provides an alternative set of instructions when the condition is false. Control flow is essential for creating interesting and useful programs. It allows us to build software that can adapt to different situations and provide meaningful responses to users. It allows our programs to handle different situations intelligently. By using control flow, we can ensure that our programs are not just a series of static instructions, but dynamic systems that can respond to a variety of inputs and conditions. In Python, we use specific statements like if, else, and elif to control the flow of our programs. These statements help us define the different paths our program can take based on the conditions we set. By mastering control flow, we can create more complex and powerful programs that can handle a wide range of tasks and scenarios. The elif statement is the most basic control flow tool in Python. It's a fundamental building block that allows programmers to make decisions in their code. It lets us run a block of code only if a certain condition is true. This is incredibly powerful because it means our programs can react to different situations dynamically. Think of it like this: if it's raining, take an umbrella. This simple decision-making process is exactly what the if statement does in programming. The action of taking an umbrella only happens if the condition, "it's raining," is true. If it's not raining, you wouldn't take an umbrella, right? This is the essence of conditional statements. Here's how it looks in Python. The syntax is straightforward and easy to understand, even for beginners. Python weather = rainy if weather = rainy. In this example, we first assign the string rainy to the variable weather. This sets up our condition for the if statement. The if statement then checks if the value of weather is equal to rainy. If the condition is true, meaning the weather is indeed rainy, the code inside the if block is executed. This is where the magic happens. The program will print "take an umbrella" to the screen. Since it is, the code inside the if block is executed and we see "take an umbrella" printed on the screen. This is a simple yet powerful example of how conditional statements work. If the value of weather was something else, like sunny, the code inside the if block would be ignored. The program would simply move on to the next line of code. This allows for flexible and dynamic programming, enabling your code to handle different scenarios effortlessly. The if statement is just the beginning of what you can do with control flow in Python. The else statement works hand in hand with if. It provides an alternative block of code to be executed if the if condition is false. Going back to our weather example, we can add an else block Python weather = sunny if weather = rainy, else. Now, since it's sunny, the if condition is false. This means the code inside the else block is executed and we see "enjoy the sunshine" printed. The else statement ensures that no matter what the value of is, our program always has an appropriate response. Sometimes we need to check multiple conditions in our code to make decisions based on different scenarios. This is especially common in programming when we want our code to respond differently depending on the input or the state of certain variables. That's where elif comes in. The elif statement in Python allows us to add multiple conditions to our if-else logic, making our code more flexible and powerful. Elif stands for else if, and lets us check for additional conditions after an initial if statement. This means that if the first condition is not met, the program will move on to check the next condition specified by the elif statement. Each elif condition is checked in order, and only the code block associated with the first true condition is executed. This helps in creating a clear and organized flow of logic in our programs. Let's look at an example to understand this better. Suppose we have a variable called weather that can take on different values like rainy, cloudy, or sunny. If weather equals sign rainy, print, don't forget your umbrella. Elif weather equals sign cloudy, print, a jacket might be a good idea. Else, print, enjoy the sunshine. In this case, if the weather variable is set to cloudy, the first if condition is false, so the code inside it is skipped. However, the elif condition is true, so we see, a jacket might be a good idea, printed. This demonstrates how elif helps us handle multiple conditions efficiently. The else block is only executed if none of the preceding if or elif conditions are true. This acts as a catch-all for any conditions that weren't explicitly handled by the if or elif statements. By using if, elif, and else statements together, we can create robust and adaptable programs that respond appropriately to a wide range of inputs and conditions. This is a fundamental concept in programming that helps us build more intelligent and responsive applications. Section 5. Making comparisons. We've seen how to use if, else, and elif to control program flow based on conditions. But how do we express these conditions in Python? This is where comparison operators come in. They allow us to compare values and determine if a condition is true or false. Here are some commonly used comparison operators. For example, checks if the value of the variable is greater than or equal to 18. These operators are essential for writing meaningful conditions in our control flow statements. Section 6. Combining conditions and or not. Sometimes we need to check multiple conditions within a single if statement. Python provides 3 logical operators to combine conditions and or and not. Python temperature equals sign 25 is underscore. Sunny equals sign, true if temperature 20 and is underscore sunny. Print, it's a perfect day for a picnic. In this case, the message is printed only if both is greater than 20 and is true. Logical operators give us more flexibility when defining the conditions for our control flow statements. Section 7. Nesting control flow statements. We can also nest control flow statements inside each other to create more complex logic. This means we can have an if statement inside another if statement, and so on. This allows us to handle increasingly intricate scenarios in our programs. Python is _weekend equals sign true have underscore plans equals sign false if is underscore weekend. Else, here, the outer if statement checks if it's the weekend. If it is, the inner if statement checks if we have plans. This nested structure allows us to tailor the program's output based on a combination of conditions. Section 8. Practical examples. Control flow is used extensively in real-world Python programs. Here are a few practical examples. User authentication. Control flow is used to check if a user's login credentials are correct. Data validation. Control flow ensures that data entered by a user meets certain criteria. Game logic. Control flow determines how a game responds to player actions. Decision-making algorithms. Control flow is at the heart of algorithms that make decisions based on data. These are just a few examples of how control flow makes Python programs more powerful and versatile. Section 9. Conclusion: Mastering control flow. Control flow is fundamental to programming in Python and many other languages. It allows us to create programs that can respond dynamically to different situations. By mastering if, else, elif, comparison operators, and logical operators, you gain the ability to write sophisticated programs that can solve a wide range of problems. The key is to practice using these concepts in different scenarios. As you gain experience, you'll be able to write increasingly complex and powerful Python programs.